Okay, so what we're going to do is we're actually going to just graph y equals sine x. And then we'll talk about what to do with that graph. Okay? Okay. So let's just graph y equals sine x. Let's graph 2 cycles of it. All right. Maya, what's a period for y equals sine x? 2 pi. So halfway point pi, half of pi, pi over 2. 1 pi over 2, 2 pi over 2. So next one is 3 pi over 2. Let's do the same on the negative side. All right, amplitude, lovely Rachel, is what? 1. All right, everybody good so far? Leah? Yeah. Sine starts up or down? Down. All right. So x-intercept, next halfway point, you're up the amplitude. Next halfway point, x-intercept. Next halfway point, down the amplitude. Next halfway point, x-intercept. X-intercept valley, x-intercept hill, x-intercept valley, x-intercept hill, x-intercept. Okay? And what we're going to do is we're going to dash this, because this is not actually the cosecant function, but it's how you get the cosecant function. Okay. All right, this is where I need you to go to your unit circle. On your unit circle, Miss Natalie, at 0, what is sine? Is what? 0. Miss Natalie, the number 0 can be written over 1. We want to graph the reciprocal function. So Miss Natalie, what's the reciprocal of that fraction? What would it be? 1 over 0, which is called undefined. So for the cosecant graph at x equals 0, we have something undefined, which would generate, what word is that, guys? What's that called, the undefined line? Something the curve cannot touch. Asymptote. Okay, thank you, ma'am. Remy, go to pi on the unit circle. What is the sign, Remy, at pi? 0 over 1. And Remy, what do we get when we flip that over? 1 over 0. Which is another asymptote. So what are we going to hypothesize happens at all the x-intercepts? There's an asymptote. For the cosecant graph, asymptotes at all the x-intercepts. Okay, so asymptotes at all x-intercepts. So what does the curve actually look like? The curve actually looks like at each of these maximums and minimum points, you have what I refer to as a U. It's a curve. If it's at a max, the U opens up. If it's at the min, the U opens down. It's a curve that can never touch those asymptotes.
Does it have to be
Drawn like this.
What if it doesn't look
It'll be fun. I'm not that picky. Okay, so this is actually the graph of y equals cosecant x. Oh, not so bad. What's it now? Okay, next one. Graph y equals secant x. So letter B. Graph y equals secant x. Well, you know what we're going to do. We're going to graph, y equals cosine x. And then we're going to see if we have any asymptotes. We are masters at graphing y equals cosine x. Nat, what is the period for cosine? 2 pi. All right, so go ahead, graph your cosine curve as dashed. Okay, and Joel, can you consult your unit circle and tell me at pi over 2, what is cosine at pi over 2? Yes. And Joel, when we reciprocal that, because we're doing the reciprocal function, what do we get? And that is called? Starts with a U? Starts with a U? Yes. So guess what? At all these x-intercepts, what do we have, gang? Asymptotes. Now you know if you're walking down the street, if somebody asks you, what's that line called that a curve never touches? You're gonna say yay, asymptotes. Same thing as the cosecant curve. On the secant curve, wherever you have a minimum, you have one of those U's that opens down. And anywhere where you have a maximum, you have a U that opens up. U that opens down.
That's not very
No. Just different asymptotes, correct? This one. A value is still 1. Period is still pi. Okay. Now, here's what happens. Draw your axes. A value is 1. Instead of the asymptotes being centered around 0, 0, for cotangent, one of the asymptotes is at 0. The other asymptote is over the period, okay? And the period is pi. So we have an asymptote at 0, x equals 0. And we have an asymptote at x equals pi. Halfway point. Mason, what's this halfway point? Yep. And this one, Mason? Pi over 4. So 1 pi over 4, 2 pi over 4. This one, Mason? 3 pi over 4. Okay. X-intercept at pi over 2. First halfway point up the A value. Second halfway point down the A value. So it kind of looks like it did when we reflected it over the x-axis. Okay. Negative pi. Negative pi over 2. Negative pi over 4. Negative 3 pi over 4.
My cousin's lady.
Asymptote and negative pi. Halfway point x-intercept. Halfway point on the left, up at 1. Halfway point on the right, down at 1. Now, so for cotangent, guys, this is going to be new for you. The asymptotes are at x equals 0 and x equals pi. You just have to remember that it's kind of flipped around.
Should we do plus or minus pi?
Pardon?
Should we do plus or minus pi or just pi?
No, you can just leave it as pi. Usually they ask you for these two asymptotes, so not all three of them. Okay? Okay. All right. Tomorrow